Hey guys, Bubba here, and today we're going to be taking a little look at metatables. Now I know I've had metatables in a few of my previous tutorials, but I felt like I should go over them a little bit more explicitly because they are extremely useful and they've got a lot of content. So, this tutorial is completely devoted to metatables and what we can do with them. Now, first off, what is a metatable? Essentially, a metatable is just a way to change the behavior of a table in Lua. We can actually, with metatables, make a table behave as a function, as a number, as a string, essentially anything. And we can really customize the way that the table reacts to different events. And so metatables are really great, and one of the most common uses for metatables is in Object-Oriented Programming. Now, you may or may not have heard of Object-Oriented Programming, but in case you haven't, I'm just going to give a little bit of a brief overview here. And just as a note, Object-Oriented Programming can be achieved without metatables, but I think that metatables make it much simpler, neater, and just better overall. But anyway, let's go ahead, and this is a multi-line comment, and let's describe how object-oriented programming works. In object-oriented programming, you have basically you can have a prototype or a default. Now, this prototype is going to essentially describe the attributes of a basic object. So for example, I like using a box as an example. Now, a box has several attributes. Every box has these attributes. It has a width, it has a depth, it has a height. Now, this box here would be our prototype, because every single box on the planet has to inherit these different things. But not every box on the planet is completely alike. Each box is a little bit different. And here's where object-oriented programming comes in. It allows you to create new boxes that inherit, let's see, this is what do you call these? Let's just say it inherits, because that's what it does. It inherits the default attributes from the prototype box, and in addition, we can set our own, a specific thing. So we could give it a logo, we could give it a color, a material, and so on and so forth. And object-oriented programming makes this really easy. And we don't have to go in and define 1,000, new boxes. We can just make a new box that has a few extra things, instead of making 100 new boxes that have width, depth, height, all those default attributes, and then adding on. So, let's go ahead and I'll describe how you can achieve object-oriented programming with metatables, and also let's go over a few other things that you can do with metatables. And in fact, let's not start with object-oriented programming, even though I explained that first. Let's start with some of the basics. First off, metatable is always going to be a table. And inside of that table, you're going to have what are called metamethods. Now, metamethods are essentially, they describe how you are changing each individual characteristic of the table. So, I will provide a link in the description of what every single one of those metamethods is. But let's just go over a few of the simple ones and the most important ones. Now every meta method is going to begin with two underscores right next to each other, and then it's going to have the name of the meta method. And just to show you how these work, let's show you the add meta method. Now, generally meta methods are functions, and what's going to happen here is it's going to take an argument a and b, and what's going to happen here is we'll have our table that we want to apply the metatable to down here, and we'll use the function setMetatable of our table that we create here to our metatable. Now what's going to happen is, because this table has the add meta method, it's going to, whenever we call the table plus anything, it's going to take table, or whichever is first. If it's 3 first, then it will put 3 in as A and table in as B. Or if we have it vice versa, then it'll be vice versa. So what we can do here is we can just define the behavior of an add in with the metatable, with the meta method. So let's just always have table plus anything return a single value, and then let's go ahead and print out what happens when we print table plus anything. 10. Perfect, that's exactly what we expected. Now there are a bunch of these mathematical sort of meta methods. There's sub, there is div, which is divide, there is, let's see here, pow, which is power, so you know, this to the power of. There is mul, which is multiply, and actually I don't know why I'm listing all of these, because I'm giving you a link, but anyway, you get the gist. There are plenty of mathematical, in fact every mathematical operation that you can do just with sort of, you know, the vanilla commands anyway, the ones that you can access on your keyboard, not the ones that you access through the math dot whatever. But anyway, yeah, all of those are available to modify the behavior of tables through meta methods. And additionally, with meta methods, we can define the behavior of equality. So the equality operation. So if I set table, I ask if table is equal to another table. Now, something to note about this is that when we perform this, these logical operators instead of the mathematical, you have to have each item in the sort of comparison both have that same metatable. So for me to describe what I mean, let's just always have this return false, and then we're going to have table 1, and we're going to have table 2, and actually let's have it return true, and then we're going to set the metatable of both of these to have the exact same metatable, and that's what I was talking about. These both need to have the exact same equality meta method for this to work. So if we print out table 1 equals table 2, oops, meta 204, that is not an error I'm very familiar with, but here's what's happened. I've forgotten to correctly call these. Alright, yeah. So you see it returns true, even though clearly table 1 is not table 2. This EQ, or this EQ meta method, returns true. So just to see this in a little bit more of a practical example, let's return a.value equals b.value, and in our table we could have it value equal 5 and value equal 10. So here it's going to return false, and if we set the value here to 5, it's going to be true. So with this, we could actually, compare a ton of values and make sure all of them match up, and then return true. So that provides us with a lot of power. And there are a bunch of these sort of logical meta methods, but I'm not going to go over any of the other ones. I think you guys get the gist of how that works. But anyway, let's move on to some of the more table-specific meta methods. Now, one of the most commonly used table-specific meta methods is, let's first, the new index meta method. And what the new index meta method does is, when we have a table that has this meta method, whenever we assign a new key to the table, what's going to happen is it's going to actually not set the key at all. It's going to go through the new index meta method. So it's going to take this table, put it into the t variable, key, put it into the k variable, and value, and put it into the v variable. So let's create our actual table here and set the meta table. And let's just make this a little bit less ambiguous. A key equals a value. And here we can just print try to set k to v. Alright. Let's see what happens here. Nothing happens. Because I tried to do the reverse operation here. I tried to set the metatable of empty to table. Alright, there we go. Tried to set a key to a value. So, and if we go in here and try to print a key, you'll see that this line is blank, which means that a key does not exist in the table. So it didn't even set it. Now, if we wanted to set if we actually wanted to go ahead and set that value in the table, we have to use a little function called raw set. And what raw set does, it avoids using any meta methods that would affect setting the value. In fact, it just avoids metatables altogether. So what happens is we can just set t, which is the table reference, and we can set the key to the value. Now, when we run this, you see that it returns a value. Now, I'll show you what happens if we just tried to set this directly. Set t, k equals v. This is what you're going to get. You're going to get, well, 204. Let's take this off. Okay, well, what 204 should be is index array out of bounds. I'm not sure why it's giving that. Yeah, there it goes. Alright, so this is giving me an array index out of bounds exception. And what that means is that when I run this, it's actually calling our table. It's actually trying to set the key of the table, and it's just going straight back up into this new index meta method, because as you can see, we're still setting the value in a regular way. So that is the reason that we need to use raw set. Now, this let's go ahead and introduce another metatable or meta method, and this is going to be the index meta method. And the index meta method could be either a function or a table. More commonly, it's a table, I would say. But And here's where we get into the object-oriented programming, which I described at the beginning of the tutorial. Now, the index is going to allow us to set default values in the table. So I could set value key thing equals default. And when we try to access something that does not exist in the table, it's going to go up here to the index meta method and ask if it has it. So for example, if I'm trying to request thing from the table, right now it's nil. There's nothing there. But if we go into this index meta method and give it a default, then now it's going to go up to the meta method and it's going to find it here. Now you can do this with a function as well, and I will give you a link in the description that will show you how you can do that. It's fairly simple, so it shouldn't take much to figure out. But anyway, so this is where we get into object-oriented programming. With this metatable, we'll be making our prototype. And let's go ahead and actually, let's call this prototype now. And we'll have in our prototype, let's do the typical box prototype, the box example here. And a box has width, height, depth, and that's it. That's what's going to be in our prototype. Now, to make this truly object-oriented programming, we can't just directly set our metatable just straight to that. What we're going to want to do here so that we can create an infinite number of boxes with different attributes is we're going to want to create a box.new function. And it's going to take the arguments self and t. And t is going to represent a table, which we'd give to it. Now, hopefully you guys are familiar with how we get self into a table, or rather a function that's in a table. All you have to do is call that function with the table : function, and that's going to pass the box table in as a self parameter. And then here we can just use a table. Now what we're going to do in this function is we're going to set the metatable of t to prototype, and then we're going to return t. Alright, and then right here we're going to create a few extra attributes which this box has. It's going to have a logo, a meat logo. I'm not going to try to think on it more than that. And it's going to have a distributor, Google, don't ask me why, and I think that's all because I'm running out of brain power by now. But anyway, and we're going to set this to my box. Alrighty, so we're going to print depth of my box. We're going to print logo of my box, and we're going to print some value that doesn't exist. Alrighty, let's go ahead and run this. Okay. I've made a mistake here. Yep, I tried to assign a nil value, so let's just do this or false. Yep, this needs to be in parentheses for it to work correctly. And actually it can't be Boolean, we'll just have an empty string there. That'll be better. There we go. Alright, so what's happened here? We print out 13 for depth, we print out meet logo for logo, and we print out nothing for nil value. This means that when we try to print depth, it went to the myBox table and it looked for a depth variable inside of there. It did not find it, so it went up to our meta method and asked if it had it there. It did, so it returned 13. The logo of myBox, it did find in the table, so it didn't look any further, and if I went ahead and showed you here, if I went and made another logo, you'll see that it's still meet logo. So it didn't go any further than the table because it didn't need to. And of course the nil value, behaves completely as normal, but of course we could change that. Actually, we could change that with an index function, and I'm not going to show you how to do that in this tutorial, but like I said, I'll provide a link and that'll explain everything. But anyway, hopefully you guys understand the basic concept of metatables. They can be a little bit complicated at times, but they're not the worst in Lua, and honestly, in comparison to most languages, metatables are pretty simple. So if you guys have any questions or comments, go ahead and make one below or in the forums, or you can email me. I'll provide my email in the description as well. And I hope you guys enjoyed. Thank you for watching. See you in the next tutorial.